Hi there. My name is Alex Strout, and I'm the Crab Team Coastal Specialist at Washington Sea Grant. Thanks for tuning in to learn more about the history of European green crabs in Washington State. Let's dive right in. As a relatively recent invasion, the history of spread of green crab along the northwest coast has been very well documented and described. Mechanisms for spread have varied and include both human-mediated and unassisted dispersal, also known as natural dispersal. Green crabs have been on the west coast of the U.S. since at least 1989, first arriving in San Francisco from the U.S. East Coast in bait packaging materials such as seaweed. One of the easiest and quickest ways green crab can spread is during their larval stage, called the zoea or spikehead phase. During this stage, larvae can survive for several months washing around in coastal ocean currents. After arriving in San Francisco, green crabs most likely began to spread during this larval stage regionally in California. Since the 1990s, warmer ocean currents associated with El Niño years have worked to facilitate the spread of green crab larvae further and further north. They were first documented in Willapa Bay, Washington in 1998, and about 10 years later, they were documented on the outer coast of Vancouver Island, BC. Detections continue to unfold further north up the west coast, and in 2022, green crabs were discovered for the first time in Alaska on Annette Island, home to the Metlakatla Indian community. Initially, green crabs were absent from the Sailor Sea, and their populations in Washington state remained fairly patchy. Here's a closer look at the trajectory of European green crab populations on Washington's Pacific coast. As I mentioned, green crabs were first detected in Willapa Bay in 1998, but only recently have their populations begun to cause concern. This graph represents the only continuous monitoring data set from Washington's coastal estuaries at a site known as Stackpole. This data was collected annually, beginning in 1998, from Dr. Sylvia Yamada, a researcher at Oregon State University, and her colleague Andrea Kemmer. While this is a limited data set collected from only one site, it does provide a glimpse into the shift that we're seeing at the estuary level. As you can see from these green bars, which represent the capture rate of green crabs, populations at this site remained low for about 20 years after they were first detected at Stackpole. The pattern reflected here is that at first, a small wave of green crabs would arrive and die off without evidence that crabs were able to sustain a population locally. Researchers were able to correlate that each of these waves has been associated with an ENSO event, which creates currents and conditions that bring larvae up from populations in the south. And this pattern was consistent even through 2015 and 2016, when green crabs peaked, but then started to disappear again. So what has changed since then? Well, we have some indication that populations in Oregon and BC, Canada have gotten much larger and more sustained over time. And it's possible that in part, these closer sources of larvae have been repeatedly flooding Washington's estuaries more so than in the past. Regardless of how it's happening, the recent changes in populations in Washington state reflect a real state change, and the patterns that we've seen in the past have shifted. In 2020, Washington Sea Grant and the Washington Department of Fish and Wildlife launched a thorough coastal population assessment of green crab and found that abundances were higher than ever previously recorded. The crabs we are seeing now are not likely the result of crabs that have been living in the bay from decades before, but a regional change that was driven by other populations outside the state, and now potentially from reproducing populations within the state. Inland Washington has followed a slightly different trajectory so far. While green crabs have been on the coast for 30 years, they didn't make it into the Sailor Sea until more recently. Part of that delayed expansion was thanks to a little help from nature, the Strait of Juan de Fuca. The strait acts as somewhat of a barrier to keep green crab larvae out of the system because surface waters mostly flow outward towards the Pacific Ocean. This pattern appeared to keep larvae from getting washed in through the strait for several decades after green crabs were found in coastal Washington and coastal BC. However, in 2012, green crabs were found for the first time in the Sook Basin, and at this point, they were numerous enough to be considered an established population. This was a worrisome discovery given the geomorphology and interconnectedness of the Salish Sea. The thought was that if reproducing populations exist within the Salish Sea, it will be easier for larvae to begin to circulate and grow a population within the basin from there. In response to this concern, Washington Sea Grant's crab team was started in 2015 as a volunteer-based early detection network with the goal of trapping for green crabs across inland Washington shorelines and as a way to detect this invader as soon as possible. The earlier an invasive species is detected in a new place, the greater chance you have to stamp it out before it grows out of control. This system proved to be incredibly effective when in 2016, the first green crab was detected in the San Juan Islands as part of this monitoring effort. Since then, the monitoring network has grown, and with it, so have green crab populations. 2017 marked the first year that an inland hotspot detection was made. A hotspot is a site or an area with a high relative abundance of green crabs compared to surrounding areas. And in 2019, we began to witness substantial spread in Whatcom and Skagit counties. Here's a look at the population trajectory using the same timeline as coastal estuaries. The first inland discovery was made in Sook Basin in 2012, and from there, the first Washington inland detection in San Juan Island in 2016. As I mentioned, populations have begun to grow, and most of this population growth that we see beginning in 2021 came from the Lummi Sea Pond in Lummi Nation. Pulling this information together, we can see that Washington has what we might call two connected but distinct invasions. When comparing coastal versus inland shorelines, we notice that the first detections were spaced apart by nearly 20 years. And this has led to a higher abundance in the coastal estuaries in nearly every location where green crabs have been found, compared to the inland populations. A big geographic distinction is that populations of green crab are more continuous in coastal estuaries because the habitat is generally more continuous. At inland sites, green crabs are often confined to smaller spaces or only portions of embayments, and this is largely because the habitat is more sparse or restricted. There is also higher exposure to larval input on the coastal estuaries, which abut the Pacific Ocean, compared to the inland waters, which again have the Strait of Juan de Fuca to largely help keep outer larvae from washing into the Salish Sea. Despite these differences, both regions are experiencing increased abundance and ongoing spread. And as a result of this, community organizations, state agencies, tribal nations, and more are working across the state to protect our coastal shorelines from negative impacts experienced by high green crab abundance. Thanks for tuning in to learn a little bit more about our state's history of the Washington green crab invasion. For more information, visit Washington Sea Grant's Crab Team website. Thanks for tuning in.